Okay, we have a 1.42 kilogram ball rolling at 2.93 meters per second toward a 0.927 kilogram ball, which gets deflected to the right at 42 degrees, going 2.18 meters per second. So what is the speed and angle of the first ball? Again, the concept that we have here is we have a ball, and the ball is moving, and then it's going to hit another ball. And so the second ball is sitting here, and we said the second ball gets hit and gets deflected to the right. So compared to the original motion, it's off to the right 42 degrees. And so the ball is going to end up over here after the collision. And so the blue ball, if the blue ball comes along and hits this green ball, of course, if the green ball gets deflected to the right, then the blue ball is going to get deflected off to the left. So we're going to end up with the blue ball over here. Now, the idea is, again, momentum is conserved. So we start off with P equals mv. Before the collision happened, all the momentum was found in the blue ball. The blue ball was the only one that was moving, so it was the only one that has momentum. So to find out how much momentum, we just take its mass times its velocity, and that would give us our momentum. Nice and simple. So 1.42 times 2.93 gives us a total of 4.16 Newton seconds going straight forward, and that's how much momentum we had before they collided. Now, after they collided, we said, well, the green one over here, it was deflected at a 42 degree angle, but we said that it was going 2.18 meters per second. So the 2.18 is its velocity, and of course the mass of that ball was 0.927. So again, we have P equals mv. We're just doing the very simple momentum formula. And that means we have a total momentum over here of 2.02 Newton seconds. And so that's how much is going that way. Well, of course, if it's going off at an angle, it's going both forward and over to the side. And again, whenever we are looking at the opposite side, we always use sine. And here we're going to look for the adjacent side, and whenever we have the adjacent side, we always use cosine. So to use this, again, we just take the sine of the angle, and then times the hypotenuse, which was the 2.02. So that tells us, we multiply that out, we get 1.35 Newton seconds that are going this way. And if we do the same thing but use cosine, we end up with 1.50 Newton seconds going forward. So these are our breaking up into a triangle. And again, we've worked with breaking into a triangle before. It's not that hard. The opposite side, the one that's across from the given angle, that one's going to use opposite, that one's going to use sine. The one that's right next to, that's part of the angle, that's going to use cosine. So we got that. Now, the other part of it, of course, is, well, what happened to the blue ball? Well, now that we know all this other stuff, it's really easy to figure out what happened to the blue ball, because, again, we know the total momentum before the collision has to equal the total momentum after the collision. So before the collision, I had this much momentum going forward. So I still need that much momentum going forward, but this time I'm going to have that much momentum going forward contained in two objects instead of just one. Well, we know that the green ball is going forward. Oh, that's tricky. We know the green ball is going forward with 1.5 Newton seconds, and this used to be going forward with 4.6 Newton seconds. So we're saying, well, we're missing some momentum going forward. We used to have 4.16 going forward, and now we only have 1.5 accounted for. So if we subtract that, then 6 minus 0 is 6. 41 minus 15 would give me 26. So 2.66. So, excuse me. Yeah, so we get 2.66 Newton seconds must be going forward contained in the blue ball. So the blue ball, again, it's going to be going forward and to the side, and the forward part of the blue ball must be 2.66. That way the 2.66 and the 1.5 have to still equal the 4.16 Newton seconds that we know has to be going forward. So again, we started off with 4.16 going forward. We still have 4.16 going forward, but now 2.66 of it is going forward in the blue ball, and 1.5 is going forward in the green ball. Before they collided, we were only going forward. So after we collide, again, all of our momentum still has to, the total momentum still has to just be going forward. But now all of a sudden we have 1.35 Newton seconds going to the right. To still have no momentum overall in total, we need to have 1.35 Newton seconds going to the left. And so if we have 1.35 to the right and 1.35 to the left, that adds up to a net momentum of 0. So that part cancels out, and that's always going to cancel out. So now that we know that that is canceled out, then it's easy. Now I have a little triangle, and you just look at the blue triangle on top there. I know two sides, and I'm looking for the hypotenuse. If I know two sides and I'm looking for the hypotenuse, I'm just going to Pythagoras. So 1.35 squared plus 2.66 squared equals r squared. And so when we just run that through our calculator, we find that that turns out to be 2.98. And again, the thing that shows up on every one of these, we're not using velocity for all of these, we're using momentum numbers going on all of our pictures here. So that's all we've got. Then, of course, we want to find the angle. Now, to find the angle, the way we always find the angle in here is we do the tangent to the -1, because we're looking for the angle. So it's second tangent. And then inside the parentheses, we're always going to put the opposite over the adjacent. Well, the opposite side of this angle that we're looking for here, opposite is the 1.35, and adjacent is right here next to it, the 2.66. We wouldn't use what's on the hypotenuse because tangent doesn't use hypotenuse. It only uses the opposite and adjacent. So you do that inside the parentheses that pops up when you hit the second tangent. And we find out that that turns out to be 27 degrees. So this angle in here is going to be 27 degrees. Now, we're almost done. We want to know what is the speed and angle of the first ball. So we just figured out the angle of the first ball is 27 degrees to the left. So that part was easy. Now, to find the speed, that one is easy also, because we know the momentum here. And again, we know that P equals mv. Well, I know the momentum, that's the P. I'm looking for the V, so I just need to bring the m down here. So I take the P that we figured out, and that's going to be 2.98, and we divide it by the m. And again, which m do I use? Well, if we're talking about the blue m here, so we need the blue momentum, we need the blue mass. And the blue mass, of course, was 1.42. So if we take the 2.98 divided by 1.42, that gives me a total of 2.10. So the speed is going to be 2.10 meters per second at 27 degrees to the left. And that's all we got to do. It's not that bad. The total momentum before forward equals the total momentum forward afterwards. It's just divided into two things. The total to the right and the total to the left are going to cancel each other out. And then it's just a matter of remembering sine and cosine.